So let's see here. I wanted to make a screencast of modeling tools. Okay, see if I can figure this out. So I'll call this modeling tools. These are tools we use to model. In this case, tools are modeling constant velocity motion. Okay. Oh, that looks ugly. Try to do better on that one. There we go. So, first thing that comes to mind is we use graphs. And we use a position graph, which is where you at different moments in time. And we use a velocity graph, which is how you're moving at different moments in time. So for constant velocity motion, where you at could look a lot of different ways. It might look like this, might look like that. The basic idea is, if it looks like this, you ain't moving. Looks like that, you go in the positive direction. Looks like that, you're going in the negative direction. So, simplest case would be an object moving in the positive direction. I know it's a steady speed because that slope is constant. It's not a changing slope. So on a where you're at graph, a constant slope means your velocity isn't changing. And if I wanted to draw my velocity graph or my how you're moving graph, it needs to look like that, right? And then we typically would you could draw, given a line, you can represent this line here with an equation. So we have equations such as, let's see, what's the classic one? We have position equals velocity times time plus initial position. And this is final position over here. That's a vector, that's a vector, that's a vector. This is an average velocity. So that's a pretty classic equation we use. And that's basically y equals mx plus b. That's the equation of that line, right? And we also have an equation for the area of this graph, right? And that equation is going to be velocity times time. So it's going to be, and that's going to tell us our displacement. So our displacement, is going to be average velocity times time. And the average velocity and the displacement are vectors, and time is a scalar. So that's basic rundown of graphs and equations, which are very important modeling tools for us. Those are the graphs and equations we typically would use when describing constant velocity motion. Another pretty interesting tool, it's quite useful, is a motion map. And motion maps we use quite often to understand a situation. So I'm going to draw a car. See, this car is moving to the right. That is in the positive direction. I'm going to draw surfboards in my car. There we go. This is what I'm going to be doing in about an hour. Driving to the beach. I'm going to put 0 over here. And whoops. And I'll make this position in meters, although it could be in any units. And then I got different marks for position. Okay. All right. And let's just say every mark is I don't know, 5. 10, that makes that 10, 15, 20, 25. It's a little hard to read, isn't it? 25, 30, 35. This is kind of annoying. 40, 45, 50. I'm doing this really detailed, but with a motion map, you don't necessarily need to be this detailed about your number line. I'm just doing it so you understand the situation really well. And I'm just going to make up a number. Let's say the car is moving like, I don't know, 5 meters per second. It's going really slow. It's driving the way I drive. So I'm going to draw a vector going this way. And I'm going to say that's the velocity at 0 seconds. And it's 5 meters per second. Okay? It's a little hard to see there. So I'll write it up there. Meters per second. That's a little better. Okay? So I haven't even started motion map yet. Motion map works like this. Every second, so this picture right here, that's what I mean is happening at 0 seconds. So that's at 0 seconds. So this is at t equals 0 seconds. Okay? What I want to do now is like start with 0 seconds, and I'm just going to use kind of the back of the car as my marking point. I'm going to say my car is right here at 20 meters at 0 seconds. So that dot right there is at t equals 0 seconds, right? Now, after 1 second, my car is going to be at 25, right? And then after another, now mine are going to be too close together. This is going to get messy. So I'm going to change things around to make it easier to see, okay? So I'm going to make my car moving a little bit faster. I'm going to say actually I want my car to be going 10 meters per second. I'm going to draw an arrow to show that. How's that look? Yeah, that's going to come out a lot nicer. Okay? So my first dot is where the car is at 0 seconds, which is about there. Then at 1 second, it's going to be about here, at 30. Then after another second, the car will be at 40. After another second, it will be at about 50 meters. Okay? If I do this right, my dots will be equally spaced when the motion is constant velocity. Okay? And so the first dot I'm going to label t equals 0 seconds. And I'm going to draw an arrow halfway to the next dot. Same thing for the next second. Same thing for the next second. And the same thing for the last second. So this goes from 0 to 1 second, 2 seconds, 3 seconds. So 1 second. And then the next arrow is 2 seconds. And then the last arrow is happening at 3 seconds. And each of these arrows shows the velocity at this moment in time. If I did this right, the velocity at 3 seconds is exactly the same as the velocity at 2 seconds, is the same as the velocity at 1 second, is the same as the velocity at 0 seconds, because the velocity isn't changing. This is what we call constant velocity motion. And that's about it. Those are the tools we use to represent constant velocity motion. I hope that helps you out.